All right, we have a few topics to go over today, and we'll try to get as many of them in as we can. And the ones that we don't, there's material available on Canvas for you to review. First thing I want to do is, I don't know if I talked about this. I have a feeling I didn't talk about this earlier in the semester. Is I want to dissect a particular statement in Java. Specifically, our examples. We have an example that looks like this. All right, where we say pizza P equals new pizza, S for small, thin crust, false. What does that actually do? And how is that different? How come we have to say new over here? But if I say int x, I can simply say int x equals 0. Well, these are, one is an object reference and one is a primitive. A primitive variable simply stores a value in a memory location like this. So if I say, we'll look at this one first. If I say int x equals 0, then in my memory, in what's called the stack, I will create in some memory location, we'll say 100, again, just made up numbers. There's a variable called x, and its value is 0. Now, if I say int y equals 0, it'll do the same thing. It'll put it in a different memory location. So if I say if x equals y, it compares the two values in the memory locations. And in this case, they're equal. So that would be true. That's an equal statement because both of those have the same value. Something happens a little bit differently when we have object references and when we have variables that are not primitives but are objects. What pizza P does is says there is a variable called P in which I can store a pizza. All right. That's the first half of the statement. That means that I can call any function that's on a pizza, I can call for P. So I can call P get size, P set size, P calculate price, P get bake time, whatever. I could call all the functions on pizza because this variable P I know stores pizzas. So the compiler won't complain if I call a function that exists on pizza. Now, what does the new part do? The new part actually creates in a different part of memory called the heap an object. And what kind of object does it create? It creates a pizza object. That's what this side says. What kind of object is created and put in here? And in fact, we initialize it with small, thin, and false. So this will be in heap location, let's say 1000. Our variable P is stored in heap location 1000. So we don't store the object in the stack, we store a pointer to the object in the stack. Now, why is that important? It's important because if I did this, I said pizza P2 equals new pizza, small, thin, and false, that's going to create a new object in heap location 2000, let's say, small, thin, false. And it'll store it somewhere on the stack, we'll say 400. And it stores that memory location of the object that was created. Now, if I say is P equal to P2, that would actually be false because this pointer is not equal to this pointer. So you're always containing the location, the value in the memory location. You're always doing that as a comparison. Now, if I were to say, continuing it on, now if I were to say pizza P3 equals P, then I'm simply copying the pointer into another memory, into another variable called P3. Then if I did a comparison, it would say that they are equal. I know it's a little confusing, but just know that when you're comparing comparing two objects to be equal, you're not comparing the value of the objects, you're comparing the value of the pointers. Okay, and this is going to become important, the scheme of things. So we're going to save this. And let's look at one of the documents that I have posted in Canvas. I have constructor rules. So with constructor rules, if I have a student, I can call student S equals new student. That's calling a constructor in the student class with no arguments. Or I can say student S1 equals new student and pass it an argument. And initialize a variable with it. Okay, this is true for all classes. If you don't define any constructors, the compiler generates a no argument constructor, and all it does is it creates the object. So if I don't, like in the very first class, I don't think I defined a pizza constructor. And I said pizza P equals new pizza. I didn't define a constructor, but the compiler generated a no argument constructor, and all it did was allocate the memory. It didn't initialize any of the variables. All right, so that's the first rule. If you define any constructor, then that no argument constructor will not be generated by the compiler. Now you can still have a no argument constructor, but you have to define it explicitly. Okay, so you can code constructors, not code constructor, you get a no argument constructor. If you code any constructors, then that automatically generated one goes away. And if you want a no argument constructor, you have to code it. You can have multiple constructors, but you can't have two where the number of arguments and type match. So I could have a constructor for a class that accepts an int, and a different constructor that accepts two ints, and a different constructor that accepts a string. What I could not have are two constructors that both only accept one int. Not allowed to do that. Because again, obviously the compiler won't know which one you want if you try to call that constructor. The number and type of arguments determine which constructor gets killed. Violent today, gets called. All right. So if I have a constructor that accepts an int and another constructor that accepts a string, if I give it a string, then that constructor gets called. If I give it an int, then that gets called. If I give it two ints, then if there's a constructor with two ints, that gets called. This is an error I see many times where it will say something like argument list doesn't match or something like that. Where you try to call a constructor and there's no constructor defined with the arguments that you're trying to pass it. And we'll look at an example of this going forward. This can call another constructor in the same class. If we call another constructor on the same class, that has to be the first command in the constructor. So this gets into what's called constructor chaining, and hopefully this becomes more clear when we look at the example. So I want to introduce these rules to you. Subclass. When you call a constructor to a subclass, the constructor parent gets called first. Super calls the superclass's constructor, and it must be the first line of code. You can't have super and this in the same constructor. If there is no super in the subclass's constructor, the no argument constructor gets called. Don't do that. Super empty will call the empty constructor. So let's look at this example that I have defined. Let's look at my pizza class. Let's open that first. We'll look at this before we look at the subclasses. We'll just look at the pizza class by itself. So I have three constructors. Pizza that accepts a single string, pizza that accepts two strings, pizza that accepts three strings. Now, notice how they're chained together. If I call the pizza with one argument, and I give us the size, that will call the constructor in pizza that has two arguments, the size, and it will default the crust to thin. That will in turn call the constructor with three arguments, the size and the crust that passes arguments, and this which gets defaulted to false. In previous examples, we would have had this set the size, this set the size, and default the crust to thin. No, we call the constructor. We chain to the constructor. This saves code. We don't have to have these set statements in several different places. And if you notice, I'm not setting the attribute directly. In the past, I would have said something like size equals arg string or arg size. We're not doing that now. We're doing that by calling the set size constructor. Why do we do that? Well, later on, we're going to put some validation in the set size method. And to validate, to make sure that it's one of the proper sizes. And therefore, we want that validation to always occur. You see this, so we're only setting the value of that size through the set method. It's protected, so we can't set it from another class. We can only call it, we can only set the size by calling the set method or calling a constructor which sets the set method. And only one constructor actually does the setting of the size method. because they chain together. The rest of it stays the same. Now I added to this example a stuffed crust pizza. And I clicked on the wrong thing. The stuffed crust pizza extends pizza. And how do we know if that's proper or not? We perform the ISA test. Is a stuffed crust pizza a pizza? Yes, it is. Therefore, it's proper to say that stuffed crust pizza extends pizza, which means that it gets all the methods except the constructors in the pizza, and it can add methods or it can override methods. Now, in this case, notice what these call. If I call and give all three arguments, it calls super and passes those three arguments. If I call with two arguments, it calls super and passes the two. If I call with one argument, it passes that single argument. It passes it to its super class, its parent class, pizza. It calls those constructors over in the pizza object. So let's look at our unit test. We're going to play around with this a little bit. I'm going to get rid of all this stuff. So we only have two pizzas, P1 and stuffed crust pizza. Now, what is different about stuffed crust pizza? The calculating the price is different. If it is small, it's $12. If it's medium, it's $16. And if it's large, it's $20. And if it has pepperoni, it's $2 more. So that's the only thing different. The bake time is assumed to be the same. I don't know if that's a good assumption or not, but that's the assumption we're making. So the only thing different about a stuffed crust pizza is it has a different calculate price method. So I have my two pizzas in here, both S thick, and we'll run this and we'll see what we get. All right, it's a little bit bigger. Go. Let's open up again so we get those settings. Something wrong. Anyhow, let's not worry about that. Let's compile it. I must not have deleted enough stuff. Let's call this P3 instead. Work. Okay, it compiles. Clear the screen. Put our blank line in between them. All right, this is our regular pizza. This is our stuffed crust. And if you notice, bake time's the same. They both have thick crust. Price is different though. $9 for pizza, $12 for a stuffed crust pizza. Why? Because stuffed crust pizza has their own calculate price, and so does pizza. So depending on the kind of pizza it is, it does the appropriate calculation. That's the whole idea of inheritance. Now, make some changes and we'll see if we can figure out what's going to happen. I'll get rid of this. You can guess something bad's probably going to happen, but let's see specifically what bad thing happens. Gives me no suitable constructors found in pizza, no arguments. It's telling me that there's no argument constructor for pizza. Well, why is it looking for a no argument constructor for pizza? Because we didn't define the super function that we're going to call. We don't define the construction in the constructor in the super class that we want to call. Therefore, it's going to call the no argument constructor. And there is no argument constructor. These are the constructors it has, and that's not applicable. So therefore, we know that we have to call a constructor in the pizza class, in the super class. What if I try to call a constructor and I give it an extra argument? I get an error, and again, same thing. There's no constructor that accepts two strings, a Boolean, and an integer. It shows me the constructors that are there, and it tells me those aren't applicable. Now, do you think I can do this? This might be a little surprising to you. Can I say this? And the answer is I can. Why can I say that? I can say that because a stuffed crust pizza is a pizza. Therefore, I can put a variable that points to a stuffed crust object. I can put that in a pointer that's set up to store pizzas. Remember, back to our first chart that we developed, first little diagram that we developed. This side says what kind of variable, what kind of object I can put in this pointer variable. So this side is about the pointer. What kind of variable can I put in that pointer? And I defined that I can put a pizza in here. That's what this means. I can put any kind of pizza though. I can put a pizza or anything that inherits from pizza, because a stuffed crust pizza is a pizza. Therefore, it will fit in the pointer that is created when this statement is executed. Now, will that affect the calculation at all? No, because this side says the kind of object we actually create over here. So if I say pizza P equals new pizza, or rather pizza P equals new stuffed crust pizza, then that's legal, but this object that's created over here is of type stuffed crust pizza. I go and compile this. It still does the proper calculation. So I can put a stuffed crust pizza in a pointer that is meant for pizzas, because stuffed crust pizzas are pizzas. But then, because I've defined it as a stuffed crust pizza, I get the methods that are on the stuffed crust pizza. That's known as polymorphism. And we'll see more examples of this next week when we look at something else. Polymorphism, in a nutshell, says that two things defined as a pizza can have different functions, can have many forms. I could put a stuffed crust pizza in there. I could put a regular pizza in there. If there was such a class as a sheet pizza, I could put that in there. As long as they inherited from pizza, I can create an object of that type and put the pointer in P3. All right. Now there's more fun with this. Delete this and start over with the zip file. So let me expand the zip file again. I did that because I wanted to get back to the other unit test. Okay, here we are. We have two orders. Let's look at those orders. We have a pickup and a delivery order. Open up test. Plus pizza. Pizza. Order. And let's open up delivery order. All right, so look at our unit test. I define these pizzas. I define actually a bunch of pizzas, and I output the results of each of them. So I've defined 4 pizzas. I then create 2 orders, a delivery order, a regular order, and a delivery order. I add 1 and 2 to the order. I add 3 and 4 and stuffed crust pizza to the delivery order. So let's compile this. Oh, I didn't run it. So order 1 has this one and this one. So it should be $38. Oh, break base time and price time. $9 and $12. That shouldn't say price time, it should just say price. 9 and 12, so that's $21 is the cost of the first order. The second one is 12 plus 9 plus 10. So 9 is 21, plus 10 is 31. This is why you label things. I didn't label things too well. These are 3 and 4. And stuffed crust pizza. Let's do that. 21. Something. This is what happens when you cut and paste code. That's pizza 3, pizza 4. Oh, I didn't output stuffed crust pizza. There we go. This. First pizza sizes. There we go. First two are on the first order, so that's 9 and 12 is 21. Last three are on the second order. So it's $9, $12, that's 21. And 12 is 33, plus the $5 delivery fee for delivery orders. Remember, the price of a delivery order is the price of all the pizzas, plus $5. And notice the bake time is 46 minutes because it's 16 minutes for the pizzas plus 30 minutes to deliver. Now, I can do this. I'm going to print out a method the address of a stuffed crust pizza. Oh no, not stuffed crust pizza. Mistake. The address of a delivery order. And I can do that. Why can I do that? Because this order is defined as a delivery order. I can save it. File it. And run it. And it tells me the address. The address is Elyria. All right, very good. Now, what if I do this? If I say order D equals new delivery order. Well, we've seen that we can do something like this because we said pizza P equals new stuffed crust pizza. So I could say order D equals new delivery order because I can save a pointer to a delivery order in an order. And it's going to create a delivery order. So I can create this and call this constructor just fine. What I can't do, if I've defined it as an order over here, I can't call any of the functions that exist on the delivery order. I can only call those on the order. But the version of the function I get is going to be the version from the delivery order. So let me save everything and run through this again. Get a compile error because orders don't have a get address. Delivery orders do. So let's look at this statement again. This specifies what kind of object can be put in that pointer. Pointer to what kind of object can be put in that memory location. And it defines what functions you can call. You can call the functions that exist on the order class. This, however, says what object is actually created, and it's going to call the constructor on the delivery order, and it's going to call the methods that exist, especially calculate price. It's going to call that, and calculate bake time. It's going to call that on the delivery order. If I do this and get rid of those two functions that were only on the delivery order, it'll run just fine. And it does the correct calculation. Still calculates the cost of order as $38. Because it adds up the 3 pieces and adds the additional $5 delivery fee. So to summarize, this says what objects you can put in the variable D. This also says what functions you can call on that variable D. You can call any function that exists on the order class. This says what object is actually created, and therefore which version of the different methods that we're going to get. Okay, a few more things I want to go over today just quickly. I'm going to point them out here on Canvas for this week. Class diagrams. This becomes important when you start talking about inheritance. And this shows how you would do a customer, have orders. An order is a superclass of special order and normal order. So that's how you show it on a diagram. Now our problems are pretty small, but when you get into larger programming assignments, it's good to create a diagram before you start coding to make sure you have your inheritance and everything correct. Here is something on test cases. Just about every one of you could write more test cases. This is kind of an extensive spreadsheet, but this is a simplified version. In other words, this tests to see that the URL opens correctly. So what do? Launch the browser, type in the URL. And this tells you what you expect to happen, and this tells you what actually happened. And if they match, then it passes. All these pass it, but you can have more extensive, in other cases, you might have an error on the balance tab. That maybe the balance page doesn't open. And that is a bug that you need to go and fix. You should test as thoroughly as possible and consider all possibilities in testing. So if I were testing this, I would test delivery orders with regular pizzas, delivery orders with stuffed crust pizzas, plain orders with regular pizzas, plain orders with stuffed crust pizzas. One thing to notice in this add pizza method in the order, it accepts any argument that's a pizza. That includes stuffed crust pizzas. And likewise, this array list that we define that holds pizzas, you can put stuffed crust pizzas in there too, because again, a stuffed crust pizza is a pizza. This is a class I created that one of your upcoming assignments contains dates in it. And dates can be a little confusing. This shows you what libraries you need to import, packages you need to import, and shows you like how to create a date with the time now, how to create a date with some date, year, month, day. Another way of creating a date. This shows you comparison. This will show as not equal because these are two different objects. Date 2 and date 3 have different pointers because we created new objects each time. If I call the equals method though on it, it will say that they're equal. Compile this and run it and see if you can understand. It tells you what dates before, what dates after, how many days are between, and so on. So take a look at this. This will be useful in upcoming assignments. This, by the way, is why we use the equals function when we compare strings, because if you compare strings by simply saying if string 1 equals string 2, then if they have different pointers, it won't work. Whereas equals looks at the value of the object, not the pointer to the object. All right, that's all I had for today. We'll either see you next week or in lab.